Howdy, everyone. Hopefully you're all here to see continuous delivery best practices with Jenkins and GKE. My name is Vic Iglesias. I'm a solutions architect with Google. My Twitter handle is there if you want to heckle me digitally. I am a huge fan of Jenkins, and I've been using Jenkins for somewhere on the order of 5 or 6 years now. I've broken Jenkins a lot. I've made Jenkins do some things that Jenkins did not want to do, and in that, I've learned some things. And then I joined Google, and I'm kind of the guy who makes these best practices kind of documentations for Jenkins at Google. My coworkers have picked up on this, and they have created a set of memes about how much I love Jenkins, like this one. Yo, dog, I heard you like Jenkins, so I wrote a Jenkins plugin to launch Jenkins pods to monitor all your Jenkins jobs. They continually come out with these, heckling me about all of my Jenkins solutions and how much I love Jenkins. So today, we're going to do a brief overview of Jenkins. How many people use Jenkins? Yeah, I usually get about a 50%, but I'd figure there'd be more like 80 or 90 here. How many people use Jenkins on GCP? All right, and how about on GKE? Okay, cool. So we'll do a brief overview. Most of you guys know what we're talking about here. Then we're going to talk about the Jenkins journey. I'm sure we've all been here before, where you start in one place and you end up molding a Jenkins installation over time. And we're going to talk about what that looks like. And then we're going to talk about how to implement the end state when you've gotten Jenkins in a good state and it's scalable and it runs well and your team is happy. Once we go through that, we'll talk about how to integrate Jenkins and Spinnaker in order to do continuous delivery. All right, so a brief overview. What is Jenkins, this Jenkins guy we've been talking about? It's a build server. You can trigger or schedule jobs or processes and run your automation steps. At some point, somebody has scripted something and they want to run it in a shared environment or run it on every commit. Jenkins gives you a really easy way to do that. We also have a pluggable architecture, which is a lot of the reason why Jenkins is used by a lot of the folks in this room. It can capture a lot of the use cases that we have and various tools that we need to integrate into our CI and CD processes. How many people use Jenkins plugins? How many people use more than 5 Jenkins plugins? More than 10? 20? Oof. All right, we should talk after. The Jenkins plugin ecosystem is what enables us to use Jenkins, but also has its downsides. You have to keep track of the plugins. They're mostly open source. You have to know the quality of the plugin. It has to have good documentation. It has to have a good upgrade strategy. So with every blessing, there is a little bit of a curse in these plugins. One of the nice things about Jenkins is it runs on the JVM, and so does its agent. So we can register nodes on various distros. So you can have Linux agents, which is what mostly I've used in the past, Windows agents, or Mac agents. How many people are using Windows or Mac with Jenkins? Yeah. Cool. So that's what we're talking about here. So when someone asks me, what do I do for my CI/CD process? I just sprinkle a little Jenkins on it. That's not always the case, but a lot of the times we can start there. So what does a Jenkins journey look like? Well, day one, Genesis, right? People have been running scripts on their computers. There's some scripts that are clobbering each other's behaviors, and you decide that you need a shared place to run these based off of git commits, which would be a really nice way to do things. So you find a machine somewhere. It's probably in the corner. It's like a Raspberry Pi, and you install Java on it. It takes up all the memory. You install Jenkins. You load up all your dependencies on there, whatever you need for your build. You might need a special version of Node or Go or some test library or something like that. And then you start running your scripts in the shared build server. So you're stoked. It's better than everybody else running in their laptops. And what you end up with is this one Jenkins master node that has the Jenkins JVM process in there, a build executor, that's a process that's actually running your builds, and all your build dependencies in there. Additionally, you have the Jenkins home file system. How many people are familiar with Jenkins home? It's really comfortable. It's our home. So in your home, you have your configuration, and that's the configuration of all your plugins, of your Jenkins server itself. You also have build artifacts, so things that you're storing after your build completes. That might be some sort of binary or things like that. The other thing that runs in that Jenkins home is your build workspaces. So your build workspaces is that scratch space that your build gets to clone your repo and do temporary things in that build process. Great. So You're stoked, people are sharing this environment, they're triggering builds off of commits or scheduling builds, but then you see this, right? How many people have seen this Jenkins? Yeah, it's painful. So something has gone wrong in your Jenkins installation. It may not be scaling appropriately. Maybe you ran out of resources on that Raspberry Pi. So what do? You scale to more nodes. So you take your build agents and you run them somewhere else. So your builds run separately. This is great. You've moved your build executor process out of your Jenkins master. You've moved your build dependencies into those Jenkins nodes, and your build workspaces. So now your Jenkins master has some room to breathe. So this is a great next step, having a static fleet distributed from your Jenkins master. But again, the build is breaking, and this time, it is because we need more disk. Those build artifacts that were on our Jenkins master have filled up our Jenkins home file system. So now we decide to start using object storage to move our artifacts off of that Jenkins master. I think you should probably use Google Cloud Storage for reasons I won't tell you about, but you think you want all of this storage to move to any other place other than your Jenkins masters, and there's various plugins that can make this happen. How many people are using an artifact plugin? Yeah. Okay, so now you're happy, you're scaling well, Jenkins master is healthy and happy. But your developers are coming to you and saying that they need competing versions of dependencies on these build agents. So now you've got the problem of figuring out, how do I label these nodes? How do I get people to run the right builds on the right systems? But instead, you decide to move to containerization. So you can run each of your builds in containers, and you get the benefit of being able to give developers exactly the dependencies that they want, and you won't clobber each other's dependencies. So now developers are happy, they have more control. Next, they come to you with the next problem. Yes, we have more control, this is great, but we're poking around the Jenkins UI too much in order to configure our jobs. So we want a way to do this in source code. And the way to do this in Jenkins is using the Jenkins pipeline plugin and creating your Jenkinsfile next to your source code. So now developers can commit code that changes the test process or the build process and the source code at the same time, and they're really happy. How many people are using Jenkins pipeline? Yes, we should get that to everyone relatively soon. So that's great. And you put pipelines everywhere. You can have your happy little pipeline world in Jenkins land, and everybody is happier that they have control over their build process. Next, your CFO comes up to you and says, hey, it's looking like we're spending quite a bit of money on this CI process. Do you think you could tune that down in any way? So you poke around and you realize, oh, I know what to do. Between 8 and 6, I have a lot of builds running, but as soon as developers leave and go home, there's no builds running on all my build agents. So you look into some way to do auto-scaling agents, so that when you kick off a build and there's no agent available, it's provisioned for you, has all your dependencies in there, and then when no builds are running, it terminates itself. And there are various ways to do this. There is a GCE plugin that allows you to do this with VMs. You can also use Kubernetes plugin to do this on GKE. We'll talk a little bit more about that. Great. So you're moving along at a pretty good clip here. Now day 412 comes along. And each team is competing for which plugins are the right plugins to have in their Jenkins installation. Right? Not every plugin is compatible with every other plugin. There is a dependency chain there. So they say, we want to have our own Jenkins installations for our team or for our sets of teams. So you figure out a way to make reproducible Jenkins installations and give them exactly the plugins that they want. So you've made everybody really happy. You have a scalable system. Now you're managing multiple Jenkins, but since they auto-scale and they have enough resources and don't over-provision resources for them, you're feeling like good as an administrator. Okay, so that was, what you need to do to be happy with Jenkins and at scale. But how do you get there today? First, you have to figure out how to deploy Jenkins, right? And in the previous slide, I showed using Helm to deploy Jenkins. One of the nice things, how many people know what Helm is? Good amount. So I'll talk a little bit about Helm. Helm is a package manager for Kubernetes. It allows you to package up applications and then install them. The packages in this context are called charts. And charts are ways to define what comes with an application. there is a Jenkins Helm chart in the community. And it provides a lot of the same defaults that you would expect for a Jenkins installation to be scalable and secure. So we leverage this in order to create our installations of Jenkins. One of the nice things about this Helm chart is it allows you to define declaratively exactly the plugins you want to have in your installation, which is super useful. So what does this look like? On the left here, we have the installation command for Jenkins. Helm install stable Jenkins, and then a values file. Stable is the name of the chart repository that this chart is coming from. Jenkins is obviously the name of the chart that we're installing. And then I pass it this values file, and this is my configuration. On the right here, you can see the configuration that I'm passing it. I have a list of plugins. I have some CPU and memory configuration. And I have some Java ops. Who knows what people are going to throw in there, but that always comes up. The next thing that I do is I disable the default agent configuration, because I want my developers in their Jenkins files to define this. And I'll show how this is possible later. The next few are the persistence, the size of the Jenkins home. Again, I don't need a huge disk, but I like to have some space in there for Jenkins to have its configurations and so forth. And the other two options, the network policy and the RBAC, are some security defaults that you can get out of the box. Cool. So what do I get by installing this Helm chart into a Kubernetes Engine cluster? First, you can use Kubernetes Engine's auto-scaling node pools, which allows you to provision new pods, and Kubernetes Engine will add new nodes to your cluster as needed. Next, we get into that world automatically where we have all of our build dependencies defined by containers. That is just the default mode that you're going to use when you're running on Kubernetes Engine. The next thing you get is ephemeral workspaces. And this is something that was really important when I was running CI systems a few years ago, is to have a clean workspace for every build. So this is going to be guaranteed for you because your Docker container is going to come up, do its work, and then that workspace is going to be cleared out. So you don't have any cruft coming in from other builds. The next thing you can have is preemptible nodes. Preemptible nodes allow you to save 70% of the cost of your nodes, but there's a trade-off. At any point, those nodes could be deprovisioned or terminated, and they will only last up to 24 hours. So if you have some builds that can be restarted, this can save you quite a bit of money out of the gate. What we see is customers running half of their nodes as preemptible and another half as regular nodes so that they can always have capacity for builds. The next thing that running on Kubernetes Engine gives you is the ability to apply soft and hard resource limits. So if I say that a build needs at least a gigabyte of RAM, I can say that it also cannot use more than 2 gigs of RAM. So I can set specifically how much resources these builds are going to use as they share a node. Cool. So how do I define these agents in my Jenkins file? And this is something that I advocate for, because you're giving over that control over to the developer, right? You're saying, you tell me how you want your build spec to look. You have various containers that you can run in here. And as you can see here, I'm just defining a Kubernetes pod. That means that I can define multiple containers if I need them and separate my build dependencies in that way. And that's really useful. The other thing that I'm doing down here is wrapping my shell commands, in this example, go test, with the container markup here. And that allows me to say which container each of these commands should run in. So really, you've handed over all of the control of the build process to the developer in source code, which is really awesome. So now that we've given them control over their environment and the build dependencies that are in there, we have to give them a way to actually build those images. The easiest way to do that would be to use Google Cloud Build, which allows you to create a trigger based off of source code. Then we'll build your image and then upload that to Google Container Registry. So a really streamlined process for them to change their build dependencies. Cool. Next, we said we want to leave our artifacts off of the Jenkins master. So we're going to install the Google Cloud Storage plugin. We're going to upload a GCP IAM service account key that has access to the projects that we want to upload our artifacts to. And then we're going to use those in our build process, usually as a post-build step, to upload our artifacts to Google Cloud Storage. This can be done in the UI or also as a pipeline step. Cool. So now let's get into the demo side of that, and we're going to demo a developer updating their image and then pushing a new build out. All right. So if we could go over to the demo laptop. Yes, I am running Linux on the desktop. Yes, it was extremely difficult to get this to show up on the screen. All right. So let's go to some code here. So this is my developer test image here. And really, it's just a Docker file that has Golang and a couple of my dependencies in there. Great. So let's say that I wanted to use the Golang RC build from Golang 111 instead of 110. I'm going to go ahead and commit that. All right. Golang 110, 111. I'm going to tag it and push that tag and the commit. Cool. So when I push this, Cloud Build is going to detect that I've created a new commit, and it's going to start building my artifact. Great. So really, I didn't have to do much in order to make that happen. I could basically ignore the fact that it did happen at all and just start adding that configuration of that base image to my Jenkins file. So in my Jenkins file, for my app, I am defining the pod that I want to run for my build. And in here, I have my test image that I just showed you. And I'm going to change from version 6.0 to 7.0, which is the one I just built. And that's really all I wanted to change at this point. So now as a developer, I can change my build setup relatively easy. And I'll just make that change to my pipeline file and commit and push that. Cool. All right. And once I push that, it's going to go ahead and be detected by Jenkins. I'm actually just going to kick a build off myself. Oops. Demo time. Let's see this here. My port forwarding wasn't working. Let's see. So let's kick that off again. All right. And so now I've got my build running inside of Jenkins. And let's see what this Jenkins file does. So in here, I have my pod definition. I'm defining two containers. One for my test image, and that's just really for running Go test. And then one for gcloud. And so I don't have to have this one mega uber image for every single thing that I want to have. I can compartmentalize these dependencies and then use them independently. And Jenkins is going to mount my workspace into each of these containers, so I don't have to worry about moving or mounting weird workspaces anywhere. So in my test image, I run go test. And then after it's done, and the tests have passed, which I'm sure were really good tests, I'm going to just run gcloud container build submit in order to build an image from my Docker file. So let's take a look at what's going on here. So here I've had my build started. We can see my commit message here. Jenkins provisioned a pod for me and then started running my tests and then the build. So if I look in my Kubernetes commands, I can see that my test pod was created, so that's great. And now it's being terminated once the build has completed. And that's because we had our image built and pushed. So our new image has been deployed, and we're happy. Cool. So that's the process of a developer kind of owning that CI process for themselves. Cool. So let's go back to the slides, and we'll keep moving along. So we talked about the CI part of Jenkins on GKE. Now we'll talk about CD, continuous delivery or continuous deployment. This is going to be your best friend. This is kind of the best tool we have today, and what we're going to use throughout this demo to talk about how to deploy to Kubernetes from Jenkins. How many people are using kubectl apply to deploy? Yeah, okay. So the first thing you're going to ask when you're using a kubectl apply or anything like this is, which cluster should I be deploying to? And in order to understand that, we first should understand how kubeconfig works. So the kubeconfig defines a bunch of clusters, and that's a name, a server URL, and some CA data. It also defines some users and ways to authenticate to those clusters. And it combines those two things into what's called a context. And the context is what tells us definitively who we should authenticate with and which cluster to authenticate to. Within your kubeconfig, you're going to have multiple of these contexts lined up. and one of them is going to be flagged as your current context. That's going to be the default context that when you run kubecontrol with no other flags is going to be used. Cool, so now that we know that, how do we use kubeconfig inside of Jenkins? Well, they have a handy plugin, again, called the Kubernetes CLI plugin. So in order to use this, we're going to upload our kubeconfig as a Jenkins administrator as a Jenkins credential. And then within our pipelines, we can use that Jenkins credential with this with kubeconfig wrapping block around our commands. So that is what sets the context for each of these commands that we run in that block. So here I have two different stages, one that deploys to Canary, one that deploys to production, and I can choose which cluster it is by setting the context name in each of those with config blocks. Cool. So now that we know where to deploy code to, how do we know how to roll out the code? So for example, we could do a blue-green deployment. How many folks do blue-green deployments? Some? Okay. So blue-green deployment in Kubernetes, without bringing Jenkins into the mix, you would have a service and a deployment. And that service would map to the deployment based on the labels. So here I have a label app and a label version. And those apply to my deployment. So now it's sending traffic to the blue version. In order to bring on my green version, I would deploy it with a different set of labels. So here I have app, my app still, but I've changed the version to green. So the service is no longer mapping to that, is not mapping to that deployment. But when I do want to map it to that deployment, I can switch the label on the service and do a blue-green deployment that way. Now, if I want to switch back, I just can switch the labels on the service. So that makes it easy to do blue-green and then roll back quickly. All right, so we haven't talked about Jenkins there. What would this look like in a pipeline? Well, first, we would want to build an image, get an artifact out there. Then we want to create a new deployment, which there are many ways to do sed and grep and awk and all kinds of things to get the right build image into your deployment. And once we do deploy that new deployment, we want to make sure we verify it somehow. And what does that mean? Well, some things you could do, there's probably more, is check that the rollout has actually completed. So you can use the kubecontrol rollout status deployment command, and that will tell you, yes, I think that I have done everything that I need to do in order to make sure that this deployment rolls out. The next thing you can do is check that all your pods are healthy and running for some period of time after. So you might run into a situation where you've deployed a deployment, and the pods come up healthy, but then crash after some amount of time. So you might want to decide how long that real healthy period is going to be for you. And you can also define some of this stuff inside of the Kubernetes manifests. Cool, so now we've verified that our deployment has succeeded as far as we know. Now we can shift traffic to it using a similar mechanism. And then again, we're going to verify that once we switch traffic over, our service is happy. So how are we going to do this? We can use kubecontrol endpoints to make sure that pods are actually mapped to our service. And this would be something to verify that your labeling scheme is correct. You may have put some bad labels in that deployment, and now your service doesn't know where to send traffic. The next thing you can do is go one level up on the load balancing side, and if you've had any HTTP load balancers provisioned with an ingress resource, you can use kubecontrol get ingress to make sure your backends are still healthy. Once those are complete and you know your service is mapped to a load balancer appropriately, you can start to run tests. Maybe it's kubecontrol run. Maybe you're hitting it from outside, but actually verify that your service is doing what it's supposed to be doing in some way, shape, or form. If these things fail, you can roll back to the previous deployment at this point. If everything succeeds, then you delete your previous deployment and move along your merry way. Great. So that's one way to deploy, which is blue-green. How many people do rolling update? A good majority. Your application has to be understanding of a rolling update, but it's a great way to deploy and the default way to deploy within Kubernetes. We will bring up new pods for you and tear down your old ones one by one. You do have some flexibility in how you roll out when you do that strategy. And your options here are, how many pods should you bring up at a time? And then how many pods can be unavailable at any given time? These two can be used with either percentages or absolute values. And I think for larger deployments, you're going to want to do percentages. For things that are relatively static, you might be able to just get away with using a number of pods. Cool. So what can I do further to make this deployment robust? One thing is the readiness and liveness probes that you attach to your pods. How many people use readiness probes? This is probably the most important thing you can do to have a robust deployment process. What is a readiness probe? The readiness probe is a way for Kubernetes to ask your app if it should send traffic to it. And that's a really key place. It's where your application and the infrastructure meet. And you have to have something that is very indicative of your service's health responding here. So for example, you can have an HTTP request. Some people have a health endpoint. You can have all kinds of different things that are checked in this endpoint. And if, for example, your application needs to reach out to a database, make sure that that database is there before you respond that you're ready to receive traffic. So you can think of all of the different dependencies in your application that would need to be there for you to have a really healthy request or a healthy response to a request that came in. This is really something really important to think about, and there's a lot of tuning you can do to get the right readiness probe in place. The next thing is graceful termination. So when your pod is going to get taken down by Kubernetes, it's going to send your pod and your containers a sig term signal. And you have to react to that signal because it's basically Kubernetes, again, the application and the infrastructure coming together to say, I'm going to tear you down. You need to stop doing what you're doing and make sure that all your requests get flushed, for example. So one example of a good way to handle the sig term, when you receive that sig term, make sure that you turn off or disable your readiness probe so that Kubernetes stops sending you traffic. If you're going to be torn down, you probably shouldn't have any more traffic coming at you. Well, after that point, you can start to finish up any connections you have and then terminate yourself gracefully. One of the options you have here is the termination grace period seconds, and that's going to allow you to define how long of time you need in order to tear down. Great. So we've talked about a lot of different things that you can do in your CD process using Jenkins and kubectl apply in your pipeline files. And now we'll look at a different approach, which is using Spinnaker. Spinnaker is a multi-cloud continuous delivery platform. Jenkins started out as a CI server. It can run anything that you need it to run. Spinnaker started out as fully focused on continuous delivery, only how to get code, an artifact, from one place to another. So if continuous delivery is this long chain of events, Jenkins is extremely good at this part, and Spinnaker is extremely good at the next part, which is actually getting your code rolled out into various environments, doing manual judgments based on whether certain metrics are looking correct. And so this is what we're going to see today. There are some interfaces between Jenkins and Spinnaker. And the two main ones are that Spinnaker pipelines can be triggered by a Jenkins job. So as a Jenkins job completes successfully, Spinnaker will check it and potentially take some information from that build result and then start its pipeline with that information. The other thing that you can do with Spinnaker and Jenkins is have Spinnaker run a Jenkins job in the middle of a pipeline. So you may have a rollout process that requires some sort of performance test in the middle, and that really is orchestrated or run by Jenkins. So you can have Spinnaker do a rollout of a deployment, run your integration test or your performance test using Jenkins, and then continue your rollout. So you don't always have to pick all of them up all at once. So in Spinnaker, you have the ability to define these triggers, and the pipeline trigger UI looks like this. You define which Spinnaker or which Jenkins master you want to point at, which job you want to run from inside that, or which job you want to detect a change in from that Jenkins master, and then potentially a properties file. And so the properties file is a way to communicate information from Jenkins into Spinnaker. And that follows the Java properties file format, which is key equals value. And so you can pass, if you create this file inside of your build process and archive it, then Spinnaker can pick it up and use this information in its pipeline to configure various steps. The other thing that I said that Spinnaker could do is kick off a Jenkins job in the middle of a pipeline. So the way that this looks is, let's say I have a Jenkins job that has these parameters. In Spinnaker, as part of my pipeline, I can create a stage that will pull in this Jenkins job and show me those parameters. It'll bring up the defaults as well, but then I can parameterize them with information from my Spinnaker pipeline. So these two interplay pretty well, and so you don't have to give up Jenkins in order to use Spinnaker or vice versa. So now we'll go through what this process actually looks like end to end, with Jenkins doing most of the CI work, and then Spinnaker picking up from there once an artifact is built. So if we could switch over to the laptop. Once I log in. All right. OK. So here I mentioned I had a web app, sample app. Here we're going to do a green-blue deployment just to be a little different. Our UI is green. Some product manager comes in with their hair on fire and says, green is no longer in. We need this to be blue. ASAP developer, make it happen. So I use my awesome coding skills to hack HTML. And I go to my green, change that to blue, wherever I see it. And I am pumped. I don't know what this error is. We're going to ignore it. That may be my downfall in this whole demo thing, but we'll see. All right, so I commit this, make it blue, and I'm going to push it. And then we're going to follow this along a little bit as it goes through our process. So again, I'm just going to kick this off so we get a build ASAP. Awesome. So first thing that's going to happen is Jenkins says, hey, I don't have any pods available for you. I need to provision one. So we should see in here that Jenkins is going to start provisioning me a pod. Cool. So it provisions me a pod just for that build. And it's going to run through our procedure, which is, again, to run our tests. Well, first check out our source code, then run our tests, and then do a build with Cloud Build. And then in Cloud Build, I'll just show you the trigger that I've set up. Oh, I don't have a trigger. I'm just building them directly. In Spinnaker, I have a trigger here that is waiting for changes to GCR. So any image that comes into a particular GCR repository, it's going to kick off this pipeline. And then I tell it that I'm going to use this Docker image that got pushed as part of a pipeline step. So in that pipeline, I deploy my backend and deploy my front end. And I tell it, right now I have a static artifact, which I just entered text, but I could pull this from a repository or a GCS bucket. And I tell it that I want to take these artifacts, or this manifest, and replace this image that's in here with the one that came in from the Docker build. So here, I have my builds running. And you'll see in here that Spinnaker is doing a lot of those things that we scripted out in our pipeline for us. It's monitoring the deployment. It's making sure that things actually get to the state that they want to get to. Spinnaker actually understands the infrastructure behind it, right? So it knows what a pod is and what it means for the pod to be healthy and so forth. So that's what's running in the background here. Let's see this. There we go. So now it's succeeded. It's actually pushed out our change. And we should have blue. And that error didn't mean anything, so yay. So if we could go back to slides. That's a very simplified view of something you could do. Spinnaker can do much more complex deployments to multiple clusters, do manual judgments, all kinds of stuff. But I just wanted to see the connective tissue between these pieces, and you can extrapolate forward with your imagination as to what your build process should be and your deployment process should be. OK, Vic. So you just gave me all this information. You're probably going to watch this on YouTube again to probably dig into some of the pieces. But what can you do today to start getting your hands dirty with some of these processes? I mentioned earlier that I've written a lot about Jenkins and GKE. And so I'll show you a few of the things that I've written. First was the Jenkins on GKE continuous delivery tutorial. And this is really using multiple branches to define environments and then having Jenkins push those environments out into Container Engine. And that is available online there. That's Jenkins on GKE continuous delivery. I also wrote one with just Container Builder or Cloud Build, as it's been renamed. And that is continuous delivery with Spinnaker on Compute Engine or Kubernetes Engine. So that's if you want to use Spinnaker and Cloud Build for your CI and CD process. But then there are some folks who are not ready to adopt Kubernetes yet. And for those folks, I have the Jenkins on GKE tutorial. And this is, I think, the easiest way to get going with those build agents that I said before that automatically autoscale and get provisioned when you need them. This, you can just basically take your even on-prem Jenkins master, enable the Jenkins GKE plugin, and get going with distributed builds on GKE. So a really easy way to onboard. And that is it. Thank you so much for listening to.